Alrighty, these videos are the second part of that proof practice packet that I handed out in last class. So on these videos, I'm going to focus on the quadrilaterals on a coordinate plane, whether that's determining what type of quadrilateral it is when given all four of the vertices, or when you're trying to determine what that fourth vertex is. As you can see, I have already plotted those points just to try to make these videos go a little bit quicker. So if you haven't done so already, I highly suggest that you can just keep up with the video, that you go ahead and pause it right now and graph those, and then we can just fly through these. So the first ones I'm going to tackle are the three where you're trying to determine the best name for this quadrilateral. And what I mean by that is it a kite, is it a trapezoid, is it a parallelogram, rectangle, rhombus, square, so on and so forth. So obviously the first step is to graph those four vertices, and then it would be wise to go ahead and just connect those dots. As I've conveyed in class, it's not entirely necessary to have an exact graph of them. You just need to be able to identify what are the opposite sides, what are the consecutive sides and opposite angles, and so on and so forth. But if you want to do this detailed, accurate graph, there's no harm or foul in that. So the first thing is to identify all of the slopes. Just get all the slopes of the sides. And when it's graphed, it's even easier to find those slopes because you can just straight up count. Just like in Algebra 1, you can just count the rise over 1, so you don't have to deal with the slope formula. But if you want to use the slope formula, that'll get you the correct answer as well. The slope formula is, let's flip it over and take a look at it. Slope is the change in y over the change in x. Identify what is your first and second point, and then identify what is your x1, your y1, and your x2, and your y2, and then go ahead and plug them in to this formula. In class, the way I'm able to do it so fast is because I know that up top it's the change in y. So how many values is it rising up or is it rising down? And then again, it's just the difference. It's the change in x. How many units are you moving to the left or to the right to get from point to point? So if I look here, my slope, I know that the numerator, the number on top, is the change in y. And so it goes from -8 to a +2. So that is a +10. It rises up 10. And you can just count that if you want. And then I can see that my change in x, it goes from 1 to 7. And so that is a change in 6. And obviously, because of the graph, I can see that that is a positive slope. So I'm going to go ahead and simplify this, and that is 5/3. So the slope of this side is a positive 5/3. If I go over to its opposite side, I see that it goes from a -5 to a +5. So once again, the change in y is 10. And then the x values go from a -4 to a +2. So once again, that is the x's change 6 units. I'll reduce this and get 5/3 as well. So I can, right off the bat, I can tell that I have one pair of opposite sides that are parallel. From there, I'm going to go to my other sides and find the slope of this. Because it's graphed, I can see that this will be a negative slope. So I'm just going to go ahead and draw in my negative sign already. If I look at my y values, they go from 5 to 2. So that is a change in 3 units. And then the x values, they go from 2 to 7. So it's a change in 5 units. And I can't simplify that fraction, so I'm going to leave it as is. Over here, I'm going to do the same thing. My change in y, again, I can see that the slope is negative, so I'm just going to go ahead and draw my negative sign. My change in y is from -5 to -8. So that's 3 units, and then the x values go from -4 to 1, so that is 5. I can't simplify that fraction, so it's just a -3/5. So I can identify that my other pair of opposite sides are parallel as well, and so that makes this a parallelogram at least. And so what you would have to do on a test is just write that, because you need to prove and you need to tell me, like, what are you observing that you are coming to this conclusion that whatever shape it is. So you would write both pairs of opposite sides parallel, therefore parallelogram. But then you can look at the slopes and analyze them more, and you can identify that the consecutive sides are perpendicular because of negative reciprocals. I have a positive 5/3 here, and when I go to the consecutive side, it is the negative reciprocal, so it's -3/5. And that happens as you continue going around to the consecutive sides, whether you go counterclockwise or clockwise. The consecutive sides, their slopes are negative reciprocals, or opposite reciprocals. Therefore, that tells me they're perpendicular. So again, you would need to write that and say that consecutive sides perpendicular, and then just say negative reciprocals. So therefore, that makes this a rectangle, because I know that these are 90-degree angles, and if a parallelogram has one 90-degree angle, then it has four 90. If objects are perpendicular, then right angles are formed, and if a parallelogram has one right angle, then it has four right angles, and so by definition, we have a parallelogram with four right angles, and that's how I know is a rectangle. And you could stop there. I mean, that's enough proof. But if you wanted to continue on and find the length of each side, that's totally fine. You'd have to use the distance formula. The distance formula is the square root of, you have the change in x, quantity squared, plus the change in y, quantity squared. And you were taking the square root of all of that. Now, again, in class, the reason I'm able to do this so quickly is because I know how to easily find the change in x and the change in y. We're just trying to figure out how many units are they changing, and it's very similar to the slope formula. This value right here is the same value as right there. That's the change in y. That's just the change in y. You're going to get the same value. And the change of x is right there. So the slope and the distance formula are extremely similar. But realize that you want the values before you simplify. So if I plugged these values into my slope formula and I'm just making this up, but if I got 8/2, well, I realize that simplifies down to 4/1, but you don't want to use these values. This isn't the true change in x, and this isn't the true change in y. Those aren't those values. You need to use these bad boys and plug them in to here. So be careful about that. So we're going to find the distance of all the sides. So I know it's the square root of, and I have my two sets of parentheses. I know that in this set of parentheses, this is the change in x, and in this set of parentheses, this is going to be the change in y. The change in x is 6 units, and the change in y are 10 units when I'm going from this point to that point. And again, there are those values right here. I notice that it is the values before I reduce. I'm not going to use 5 and 3. That's just the reduced fraction. I need to use the original values. So when I simplify this, I'm going to get that this is the square root of 136. And you may be able to simplify that, but when you're just trying to see if segments are congruent, you don't need to waste your time simplifying these radicals. Like, you know the answer is square root of 136, so you need to make sure that the other side is that as well. And the other side is, because again, I'm just going to take the change in x squared plus the change in y squared, and it was the same because the slopes were the same. So over here I'm going to get that it's the square root of 136 as well. For my other set of sides, I've got, and notice how I give myself the outline. I know what the distance formula is, I know how it works, so all I got to do is just plug these values in. But I know what needs to go in the set of parentheses. And in the first set of parentheses, it is your change in x. That's your run. And so this was 5, and then the change in y from these 2 points was 3. And so that is the square root of 25 plus 9, so that gives me 34. And the same exact thing happens down here. We're also going to get the square root of 34 for this side. So I've shown that both pairs of opposite sides are congruent. That's another way of proving that a quadrilateral is a parallelogram. If you wanted to go a completely different route, you need to know other ways. And so if we wanted to go a completely different route, there's a lot written on this one. So let me get a new copy. And let me get a new copy, and we'll look at a different way to prove that this is a rectangle. So here's the same problem. Sorry, I spilled my coffee. But this is that. This is 2. Okay. So you would need to find the slopes to prove that it's a parallelogram. But then you could use your diagonals. And if you have a parallelogram with congruent diagonals, then that means it is a rectangle. So proving that this is a rectangle by the diagonals, you just have to find the distance between those. So the distance of the first one, I'm going to use these 2 values here. My change in again, give yourself the outline. And this first set of parentheses is the change in x. Well, I start at 1 and I go to 2, so that's a change in 1. And then for my y values, it's quite a bit. I go from -8 all the way up to +5, so that's a change in 13. So you can simplify that, and so I have 13 squared is 169 plus 1 squared, which is just 1, so I got the square root of 170. Or you could just count this and say, well, the change in y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and write that in there, and then change in x is just 1. That's another way of going about it. It's just simply counting. So I've got my first diagonal is the square root of 170. The other one, writing all over my coffee. The other one, this guy right here, it goes from -4, -5 to 7, 2. So it's going to be the change in x right here, goes in that set of parentheses, from -4 to 7, that's changing quite a bit. That's changing 11 units. Or you could just count over to see how many units you have to jump to get to the next x value. And then it goes from -5 all the way up to +2, so that's a change in 7. Simplify this. This is going to be 11 squared is 121 plus 7 squared is 49. And so 121 plus 49 gives you 170. And so we can see, hey, the diagonals are congruent, and the only way that can happen is, well, you can show that it is a rectangle that way. That's just another way to go about it. Moving on to the next quadrilateral. Well, one thing I want to point out is if you choose to go this route, remember that this also could be a square. So you would have to show that this is not a square. And again, graphing is not enough. You need to use the slopes, because the slopes, if they're perpendicular, then they're a square.